lives of people around me. I'm starting out with this scenario because I want to land the fact that artificial intelligence and the AI applications are going to make a huge difference to every single person that is around us in the years to come. This particular example is a very cool one as well, technologically speaking, because it's made by the eSmart Systems in working with Microsoft, and it is about creating a connected drone. The challenge is that eSmart Systems provides services to power supply companies, and these power supply companies, the primary big issue on their hands is power line inspections. And traditionally, power line inspections are unreliable and risky even because to a large extent, a lot of those inspections were being done by flying a helicopter really low above the power poles and someone either observing or taking a set of pictures of what those poles looked like and then having an analysis later. But there are a few challenges in this. One, of course, it's super risky to be flying a helicopter right above the power lines. But more importantly, even the set of pictures, there is a level at which it is very hard for humans to scale. And that's where AI comes to the rescue. The solution that we had created with the eSmart Systems is one of a connected drone. And in a connected drone, we fly a drone right up near the tops of these power poles. And the drone is taking a ton of pictures. And these pictures are streamed in. And there is a deep learning model which is looking for anomalies. It's looking for wear and tear. It's looking for breakages. It's also looking for unusual things like birds' nests on top of these poles, which makes the process of flagging where the work needs to get done extremely reliable and also super not risky, to humans at least. So with that in mind, let's move over and see how Azure Machine Learning helps us create such really amazing AI solutions. As a part of that conversation, I would like to set it up in the context of some key trends and some challenges that are there in the data science and AI space today. The key trends are around an accelerating adoption of AI by developers. This is primarily around consumption of models, AI models, which is all goodness because what that essentially is indicating or signaling is that the industry as a whole is beginning to embed these AI models into their business processes at a fast pace. The rise of hybrid training and scoring scenarios is the next interesting trend. And that trend also kind of reflects to the fact that not so long ago, you could stand up a cluster and you would be doing your data preparation, your model training, as well as your deployment, all in that cluster. And life would be awesome. But not anymore. I was just talking to a customer the other day who has a lot of information, data that is sitting and which they want to use to actually train their models. But here is the scenario that they described. They would like to take that large data sets that they have and use a data preparation capability on HDI and then pare that data down to a manageable level before they do model training. And that model training, they want to do it on a GPU VM. And finally, once the model is ready, they would like to take the model and deploy it on Kubernetes in a super high availability service. So as you can see, these are all very different systems, but they all need to be working together within that AI workflow in order for this project to be successful. That actually leads us very well into the next one, which is to push the scoring and inference to the event where it's happening, which could be in the edge, it could be in the cloud, it could be on-premise. And this is something that Azure Machine Learning is super committed to. We just announced the ability for Azure Machine Learning models to be deployed on Azure IoT devices. And this is something where we see there is going to be a tremendous amount of growth in the future. And last but not the least, the growth of diverse hardware, CPUs, GPUs, FPGAs, ASICs. There are so many of these that are actually coming up, which again make it really important for developers to understand what it is that they offer, but also it gives them the flexibility of actually picking and choosing these different hardwares and computes for the best performance and outcome for the project. After looking at the key trends, it's super important to also balance it out with the challenges that are there in the system. And the challenges essentially are data prep. Every single data scientist that I have talked to talks about the pain of data prep. And data preparation consumes almost 50 to 80% of their time, depending on the project and depending on the data sets. And the model deployment and management is probably the one that is actually the, putting the most amount of sleepless nights in the heads of the CIOs and the CTOs of different companies. Because while it's straightforward to think that, oh, we're going to go ahead, take a data preparation, workflow, we're going to build a model. Now we have a model that we're going to deploy. The challenge is that these models that are deployed are then being used by hundreds and thousands of people within your organization to make decisions. And it becomes super important from an auditability point of view, from a lineage point of view, as well as just from maintainability point of view, to know and understand where every model is and who are the users for that model. And that's where the model deployment, management, and lineage scenarios become challenging. And last but not the least, as probably everyone who is in data science can vouch for, it's super hard to explain some of these models to end business stakeholders in order for the business stakeholders to be able to take a dependency and change business process. So that's also something that we see as a challenge that we look forward to investing in. The AI development lifecycle itself spreads across an ingestion of data. There is storage and manipulation. There is preparation and training, as well as the model creation, management, and serving up the model. But the Azure Machine Learning as a product focuses primarily on the latter part of this lifecycle. And we will look at a deep dive into what exactly are the steps that we hope to make more efficient. So what do we have already? We already had shipped the Azure Machine Learning Studio as a product for the last couple of years. And the offering was primarily targeted towards the emerging data scientists who would take the graphical build capability to rapidly create and deploy experiments. And this was very well received, and we have hundreds of thousands of deployed models on this service today, which is serving up billions of requests. However, we've also heard a lot of feedback from these customers, and their feedback is very, very unanimous. It's the users love the convenience of what we have shipped. However, they also need greater control over the choice of compute and data, and they need more options in terms of the model deployment processes and the flexibility to actually use frameworks of their choice. So to leverage CNTK, TensorFlow, Caffe, or what have you that actually comes up. So with that in mind, the goals of the preview that we've just announced are building and deploying and managing models at scale. So providing that flexibility for you to scale up or scale down according to your needs. Boosting the productivity with agile development of the data scientists that are working on the AI workflow. So essentially boosting up the efficiency of the system. And last but not the least, enabling the build now with the tools and platforms of choice. Essentially an open platform that allows you to bring in all the libraries, third-party, open source, into that AI project and make it as effective as you can make it from a developer standpoint. So what are the different parts of the Azure Machine Learning preview? So there are the Azure Machine Learning services. There are essentially two services. There is the experimentation service and the model management service. And there is the Azure Machine Learning Workbench, which is the Visual Studio Code tools for AI. And together, what these allow you to do is to be able to train and deploy across Azure as well as on-premises and edge options of computes. So how do I get a preview? This is the Azure portal, and I'm in the Azure portal, and when I'm looking at the AI and Cognitive Services tab, I see Machine Learning Experimentation Preview listed right up top. And I can go ahead and provide a name and provide a subscription as well as some other information. And as I scroll down, I can provide also, I can choose to create the model management account along with my experimentation account. So as soon as I do this, what is essentially happening is I am getting an experimentation account, which is going to help me keep track of the projects, including every single run that's happening on that project. I'm also getting the ability to submit editor, which is something that a lot of you might also be using. So we have all of those on the left. And then the Azure Machine Learning Experimentation Platform essentially allows you to work with these tools and submit jobs to local machine, to scale up to DSVMs, scale out to Spark on HD Insight, as well as in the future, we will be allowing you to submit jobs to Batch AI as well as the ML server. And as a part of the service, you will be able to manage your project dependencies. And this is one of the places where we've heard, again, a lot of feedback from users, because the challenge is that you can get a machine learning model done and working on your laptop, but then when you go to deploy it, when you go to scale it up on a different machine, all kinds of dependencies are broken. And that makes it very challenging to actually figure out how this particular model that was working perfectly on your laptop or on a VM should now be working on a different compute. And we take care of all of that. So what the Azure Machine Learning Experimentation Service does is it actually ensures that your dependencies are all tracked, and that when you submit these jobs, it actually is going to ensure that the target compute has all of the dependencies that your project needs in order for it to work. It helps manage training the jobs locally as well as scaled up and scaled out, as I just mentioned. The other really important capability, and this actually comes from the fact that to a large extent, the machine learning and AI tool set until now was primarily focused on the AI, the machine learning workflow that was being used by data scientists. But with an increasing flow of AI developers coming into the picture, there is a lot more of the SDLC and the SDE capabilities that are required and expected in the AI projects. So with that in mind, we have actually created a Git-based checkpointing system and version control system as a backing for every project in Azure Machine Learning. And what this enables you to do is to essentially have a project that is shared across multiple users. There are multiple users working on and collaborating on the project. However, they all have the beautiful separation that Git allows you to have. You could be working on different branches. You could actually be working on, and you'll be working on your local Git repo. And all of that can then get merged together using standard Git workflows. In addition to that, the checkpointing, and that was the version control. In addition to that, for the checkpointing, what the Azure Machine Learning Experimentation Service does is every run that you do with the Azure Machine Learning system gets auto checkpointed. And that allows you the ability to actually just go to different runs and take a look at what was the code that was executing, and provides you the reproducibility that you need in order for you to have a really reliable AI workflow. The service side capture of run metrics, output logs, and models is also tremendously valuable. What we mean by this is today, when data scientists talk about the AI projects. They also talk about the fact that they have to kind of make sure they keep in mind what were the outputs for which runs and how were the metrics comparing between runs, and all of that is something that they handle and track. You don't have to do that anymore. In the Azure Machine Learning Experimentation Service, as soon as you hit the run button, you are able to bring up all of the service starts capturing all of the outputs and the run metrics per run and saves that in a state where you can get to. And at that point, you have the ability to further promote that and keep different artifacts from runs in a way that you can get to them easier. So for example, if you had 15 runs, you could just check mark 1 or 2 of those models as assets, and then you have a special way to get back to those models for use in a later step in the workflow. And last but not the least, you can use your favorite IDE. And of course, we have the command line interface that enables you to be productive from day one. So what did I get when I signed up for the model management service? What I got was essentially an Azure Machine Learning model management service, which talks primarily using Docker to enable the deployment of these models either in a single node deployment, which could be on-prem, on the cloud, or even on Raspberry Pi. And of course, on the Azure Container Service, the Azure IoT Edge, or the Microsoft Machine Learning Server, as well as Spark clusters. And SQL Server support will be coming very soon, so that is something that we will add to the capability as well. So what happens when you do management of models? We support the ability to deploy and manage the models as an HTTP service. And the container-based hosting of these can be either real-time or batch process. So you can actually support both of those scenarios. The management and monitoring through Azure Application Insights gives you the ability to really fine-tune the actual decisions that you need to be making in order to actually scale up the deployment or scale down in terms of the access from different business applications. The first-class support of Spark ML, Python, as well as CNTK and TensorFlow and R is absolutely something that our customers love. In addition, we are looking to add other supports through an extensibility system such as Caffe and MXNet. The coolest capability that we've talked about with the publishing of the model, the model using the Azure Machine Learning Model Management account is what I call the Excel magic. And this is essentially a feature that we're working on actively and should be available soon as a public preview. And the idea here is to be able to take the power of these models and embed them right inside the tools that are being used by the data analysts and business analysts every single day within your organizations. So Azure Machine Learning models that are published using the model management account can be used directly within by calling the Excel function. It's an Excel custom function extensibility that we are leveraging in order for us to be able to show up these models as Excel functions. So the third thing that we actually got as a part of the sign-up was the Azure Machine Learning Workbench. So what is the Workbench? The Workbench is essentially an installed tool that is available for Windows and Mac today. And I think of this as a companion app. It's a companion app for AI development because as developers, we do tend to use our IDEs as our primary development tool. And to be super clear, it is absolutely possible with everything that I've spoken today to actually live and breathe just in your IDE and not have to open up the Azure Machine Learning Workbench. However, the Azure Machine Learning Workbench is targeted to make your AI lifecycle simpler by having the right set of capabilities, such as an embedded Jupyter notebook, as well as run history and comparison experiences that I will show you in the demo. Additionally, there is a very deep data wrangling experience, which we call the AI-assisted data wrangling, which targets directly at the feedback that we've heard back from data scientists over and over that data wrangling takes up too much of their time. Consequently, this data wrangling experience that we've invested in really focuses on simplifying the ability to get the data, understand it, and prep the data for the machine learning model training experience to get kicked off. And we heavily leverage the PROS capability, which is program synthesis by example. And this capability essentially is AI for AI, because we've embedded the ability for an AI system to understand your intent and then try to find out which is the right program that you're trying to use in order for you to change your data, in order to transform your data. And we'll look at a demo of this when we get into the demos. We also allow you to extend and customize the transforms and featureize through Python. So there is a lot of extensibility capability that is built in. And we generate both Python and PySpark for execution at scale. So you can take all of the data wrangling steps that you're creating and then operationalize that if you wanted at scale. So just deep diving a little bit about PROS. What is PROS? So PROS is essentially a program synthesis framework that has its own domain-specific language. And what it does is, as the user is specifying an example, which is basically an intent, the program synthesis framework then creates a valid set of programs that it thinks will fit this particular intent. And usually these run in thousands. It's creating these thousands of programs, but then it's a ranked set. And for ranking, we actually use machine learning. So there is a ranker that is thinking through and understanding the intent of what you're trying to say using your example. And then it ranks that particular program highest, and it shows you the output. At that point, the user is actually faced with a question. The question is this what I intended? In which case, I can go ahead and it is super clear, and it is the intended program, so I'm done. And if it is not, then I need to give it a few more examples, which means I'm refining the intent a little bit. I'm making myself more clear. And at that point, the system actually understands and ranks the program that you are requesting higher, and it shows up in the UI. So it all sounds very cool, but let's actually do this the dev way. So if, as a dev, I was given a string that's on the screen right now, which is Monday through Friday, 7 a.m. to 6 p.m., Saturday, 9 a.m. to 5 p.m., and Sunday closed. This is a string that basically is stored hours for some store. And if I had to just parse it using delimiters, there are a bunch of delimiters in this. There is the colon, there is the hyphen, as well as there is the comma. Now, the interesting thing about parsing with these is that it would actually take a standard format, like a 192.128.138.20 as an IP address. And it actually kept that intact. It also kept the date format intact. And it split all of them across very logical boundaries. And this is where I think the key distinction is. It isn't just a brute force example. So we aren't trying to replace a brute force system of actually going in and doing delimiters. It is a very smart way of figuring out the intent-based and situational delimiting that PROS is doing. With that, we jump into the last thing that we get as a part of the sign-up, and then we will be ready to get into the demo. So Visual Studio Code Tools for AI is a specific investment that we've done to make the Visual Studio Code have a deep integration with the Azure Machine Learning stack. So this provides you an end-to-end development environment, and you can basically go through the entire project training experience and even remote training experience right from within Visual Studio Code. It also allows you to manage your jobs from within that. And additionally, on top of all of that, it is Visual Studio Code, which is a cool, really cool capability from the Visual Studio team. So let's jump into the demo. As a part of the demo, I'd like to set up the demo scenario first. I am passionate about working on projects that make a difference, as I said before. And this was one of the projects that I happened to work on, which I'm excited to share with you. So the Snow Leopard Trust essentially is a few very passionate people that are working to save the snow leopards from extinction. There are just 3,900 to 6,500 individual snow leopards left in the wild. And the challenge with this program of trying to save the snow leopards is the fact that these are shy and nocturnal creatures. These creatures live in really remote regions of the world. They are in very mountainous regions and sometimes very inaccessible ones too. So the challenge is to try to get the data necessary in order to actually make a difference and find the cause for the decline in numbers. So camera trapping was used as one of the capabilities by the Snow Leopard Trust, and they have been doing this for quite a while now, and they've collected almost 1.3 million images. And on an average day, an image could actually look like that, where the snow leopard is on the right-hand side corner of the image. And as you can see, it's very well camouflaged. But additionally, looking at these images and having them manually classified for identification of snow leopards is a very expensive process for a really small nonprofit organization. The Snow Leopard Trust was spending almost 300 man-hours or volunteer hours in actually trying to get these things classified. And that's where the Microsoft's machine learning platform came to the rescue. Because what we did was we took the standard ResNet 50 model, and when we ran the snow leopard data through that, we got a certain response. It was not great, and I'll show you in a minute what the accuracy was. But then what we did was we did what is called as transfer learning, where we chopped off the last few layers, and then we trained a logistic regression classifier, and we got much better results. So we could improve the accuracy from 68% all the way up to 89%, which is phenomenal for a really small nonprofit organization, because now they can take all of that volunteer hours and spend it towards something else that makes a true difference to the lives of these snow leopards. So with that in mind, let me jump into my Azure Machine Learning Workbench. So here I am in the Azure Machine Learning Workbench tool. And as you can see, I can see a list of projects on the left-hand side. And I can see them classified in groups called work groups. So I'm going to go into my snow leopard analysis project. And I'm going to bring in the data for this project, which has been shared to me from the Snow Leopard Trust. So they've given me an Excel, which contains some metadata about this, the images that they have captured. And as I'm actually bringing that data in, I do have quite a bit of tweaks that I can use if I wanted to. In this case, this is a pretty straightforward Excel, so I'm just going to bring that in. I can actually go ahead and take a look at the columns, and since everything looks good, I'm going to go ahead and also just pick up the full file. And as you can see, I do have multiple sampling strategies that I can use to sample down if I so choose. But since this is not a huge file, I'm just going to go ahead and bring the entire file in. So I have here with me a path, a couple of timestamps, and an extra column. And what I could do is actually take a quick peek at the metrics capability associated with the data sources inside of the workbench. And since this is a fairly simple image metadata file, I'm going to go ahead and jump in and create my snow leopard dprep file on top of this data source. So what is happening here is I am going to go ahead and clean up this data source. Let me get some more space on the screen and show you exactly what it looks like. So I have a path and I have two timestamp columns. And in working with the Snow Leopard Trust, they basically told us that different types of cameras were giving them different time. An anomaly to the rows that we looked at initially. And the pro system was smart enough to actually go in and pick up 1339 and not really just look at the entire string after the last underscore. So as I mentioned, there is an intent that it's trying to understand, and it is going ahead and picking that up and surfacing it. That was a fairly straightforward extraction, but you can also do something different, which is I am going to try and label this data set. And I am going to say that all the images that are in the other images folder, I am going to associate a label of 0, not true, right? And again, this is analyzing, and this is a slightly harder extraction, and so usually what it will do is it will actually give me some suggested rows where it isn't very sure what is going on. So I'm going to go ahead and give it a few more examples. So in this case, I've given it zeros, and then I'm going to scroll down where the snow leopard images is, because remember, we sorted the list. And I'm going to go ahead and give it a 1 in all of the places where the snow leopard images are. And sure enough, it's actually gone ahead and completed that transformation. And it is actually pointing to the set of rows that it isn't sure about. So now I go ahead and look at that fact that it isn't able to guess for the other images. So I add in one more. So at this point, I've given it 4 examples. And so now what it's done is it has completed the transformation. I do see that there are some rows that are missing. So there is a little bit of an odd experience here, which is unusual. So let me go ahead and fix that problem. And usually, with about 4 examples, it actually does a phenomenal job. This was a very unusual one that it needed 5 or 6. There is something odd going on in my demo right now. But so it did go ahead and classify all of them right now. And this indicator here tells me that I'm not missing any more rows, and I don't see any anomalies. One way to actually check for the anomalies would be that I would select that column. And let me go ahead and set that up. I will go ahead and select the column. I would look at a value counts inspector. And as you can see, there are only zeros and ones and about 798, which looks about right from the query that I had done earlier in terms of how many should have gotten marked as a 1. So there are about 798 rows of data that are snow leopard classified as snow leopards, and about 2,800 which are classified as not snow leopards. So that's what this data is telling us. Now that was all awesome. So with this in mind, what you're seeing here is the set of steps that you took to transform this data. And what you can do is you can actually move around, and it actually goes ahead and brings the data set back to the shape that it was in before. So if I did not want to see the initial file name, I can take that out, I can bring that back. And so it kind of gives you the flexibility of going step by step and moving back and forth between the steps that you're doing in order to get what you need in terms of the data transformation. At this point, I can go ahead and generate some code from it. And this code is basically the access code that I can use to generate, to run this transformation and create the data frame that I need to use in my modeling. So if it's 50, and I am also defining the number of output layers that I'm chopping off. So these were all the ones that I pointed out already. So I'm going to scroll past and go down to the place where there are additional things that I am logging. So I am logging the number of layers that I'm cutting out. And I'm also going to go ahead and log, after I train the logistic regression feature classifier, I can go ahead and log the accuracy as well as the area under ROC. So with these elements logged, I can go ahead and use the command palette to submit an AI submit job. So this is the action that I can submit, and it automatically is integrated with Azure Machine Learning such that it allows me to pick the run configuration that I'm looking for. So what I'm going to do right here is by picking the my HDI, I'm actually taking this code and running it directly on a HDI that I have already gone ahead and set up and configured, an HD Insight instance. So this statement right here, Azure Machine Learning AM experiment submit -c my HDI and snowleopard.py is an Azure Machine Learning command line prompt. And by actually using that, we are able to create this integration for submitting these from within here. You can go ahead and use the terminal window directly and type it out, or you can additionally also switch back to the command prompt and directly do that from the command prompt of the Azure Machine Learning workbench as well. So now that we've actually submitted that, while it's running, it actually does take a bit of quite a few minutes to run. I'm going to go ahead and walk you through what the run history looks like. So the Azure Machine Learning Workbench's promise was that it would allow you to track run over run comparisons, and that's what we're doing here. So I've actually been running with different layers and different layers cut off, as well as the accuracy has been varying across that. So I have here a set of runs, and as I can see that when the layers were cut at when 3 layers were cut out, I got the maximum accuracy. And so those were the runs between 10 and 15. So I can actually go ahead and take a look at that. Additionally, I can actually compare multiple runs. So I can go ahead and look at, say, runs 14 and 15 and hit the compare runs capability. And this will let me bring it up side by side. I can take a look at these numbers side by side and really figure out which one it is that I want to take a dependency on, right? These two look pretty darn close. So I'm just going to pick one and I'm going to go with it. So I can, at the time when I know which run it is that I want to focus in on, I can go ahead and click into that run. And as you can see, for every run, we actually save the set of output assets that you have called out. So in this case, the outputs that we have saved is the actual snow leopard pipeline that was created at the end of that run. So, and what I can do is I can now promote that, and what that does is it actually creates an asset for me within my project, so that it actually creates a link to that asset in a way that that asset is something that I can retrieve very quickly with a smaller list, instead of trying to go into a specific run and then pulling that asset back up. So in the interest of time, now that we actually have an asset, I am going to jump into the command prompt that I already had open, and I am going to go ahead and show you how we can operationalize this model. Since this was a model that was already created, what I'm going to do is I'm going to use the AZML service create real time with the model name that we just looked at, right? And I'm giving it the model name. I'm giving it a scoring file as well as a name, and I'm going to go ahead and change that name. And I'm also calling out that I am interested in PySpark. So this does take quite a bit of time. So again, I'm going to set it off and jump over to the service that I had already created. And I just wanted to show you how this kind of ends up looking in an end business application. So this was a service that was created and has already, it's a real-time service. And what we did was we slapped on a really nice looking UI, a web page on top of that. And what I can do is if I actually went in and submitted a photo through that, a photo that was actually taken from the camera trap, and I submitted it to this service, the service actually does a real-time evaluation of that image and comes back with whether it's a snow leopard or not. And in this particular case, because it happens to be a goat image, it better not have been a snow leopard. So let's try actually the really well-camouflaged snow leopard image as well. So I'm going ahead and submitting the one that was the well-camouflaged snow leopard image, and it does recognize that as a snow leopard. So with that, what I wanted to land was that it's possible for you to go ahead and take the data from a particular project, go through the data preparation steps, go through the model building steps, not just locally, but being able to submit those jobs across remote computes, using that into the project using that at the time of project creation, or even subsequently providing that into the project update CLI command would actually make sure that the project is stored in the cloud repository, thereby making it possible for multiple users to be able to see it as well as work on it. So we did look at the data preparation in Workbench. We looked at how the coding experience works, how the IDE experience works. We looked at job submission via the VS Code path on a remote HDI cluster. we looked at run comparison within Workbench, and also the notebooks capability is available on Workbench. I did not show you that. I can show you that really quick. So the embedded notebooks is a capability where you can do quick REPL checks for what it is that you're trying to do. And this allows you to actually build your code up in a way that is easy to debug. So you can go through this experience and use this by coming into the notebooks. You can actually start the notebook server, and at that point, it's actually initializing the kernel for you, and you can then start using this notebook, which is saved along with the project. Again, that's the beauty of this, which is now this notebook is actually traveling along with your project. So it's actually all of the project contents in one place. So once you do have the notebook server enabled, then you can start going ahead and using the REPL capabilities and making it super powerful for your project. We did look at model deployment, and last but not the least, we did look at scoring. So service pricing. These are basically, like I said, there are two separate accounts. There is the experimentation account and the model management account. The experimentation account is charged per user, and there are different tiers. And the first two are free. The model management account is, again, tiers based on the deployment scale as to how many different models you want to host. And there is a dev test here, which is free for you to try out. So again, the basic first two experimentation account user seats are free, and subsequent seats will have a charge of about $50 per month. So the Workbench, which is the Azure Machine Learning Workbench application, as well as the Visual Studio Code for tools for AI, all of these are just free applications that are available for you. So what's next? What's next is, let's get started. You can learn more on http://azure.com/ml. And there is a ton of amazing tutorials and videos and documentation to go try out. And tell us what you think. We take feedback right from within the application. So do click on the smiley face and feel free to send us if you feel happy, as well as if you feel sad. And we take a look at these very actively. We love to hear from you, and we will be super actionable on the feedback that we're getting from the community. As a roadmap text, I just wanted to add that there is a support for AI, for Azure Batch AI that we are looking at enabling very soon. We're also looking out to roll out this capability across a few more regions in Azure. But we would love to hear from you where you want us to roll out to. So please do give us that feedback. Our next milestone is the GA milestone. So we are in public preview right now. We would love to get to general availability soon. And so that's what we are marching towards. But we're listening along the way. So please do give us feedback, and we will use that feedback to prioritize all of the work that is happening for GA. Thank you.